Now, in this lecture, we will find the radius of a circle. As you can see in the drawing, we have a circle. The center of this circle is at point O. Chord AD equals to 10 units, and chord BC equals to 5 units, and this angle is 90 degrees, and we want to find out the radius of this circle. First of all, I will explain you what is a peripheral angle. Okay, the definition of a peripheral angle a peripheral angle is an angle inside the circle its vertex is on the circle and its curves are chords in the circle. So I will read again the definition of a peripheral angle. A peripheral angle is an angle inside the circle. Its vertex is on the circle and its curves are chords in the circle. I will give you an example of a peripheral angle. Angle alpha is a peripheral angle because, first of all, it is inside the circle, and also its vertex is on the circle, and curve AB of angle alpha is chord in this circle, and also curve AC of angle alpha is chord in this circle. And angle alpha rests on chord BC. Okay. Again, a peripheral angle is an angle that is in the circle. The vertex of angle alpha is a point on the circle. Here, the vertex of peripheral angle is a point on the circle. Here, the vertex of angle alpha is at point A, and point A is point on the circle, and also curve AB is chord in this circle, and also curve AC of angle alpha is chord in this circle, and angle alpha rests on chord BC in this circle. So that is an example of a peripheral angle. In the next step, we will draw a chord for points A and O. You should remember that point O is the center of this circle. The touching point between the chord and the circle is at point M. The touching point will be called point M. Again, the touching point between the chord and the circle is at point M, or we defined it as point M. And actually, chord AM is the diameter of this circle. I will write it down. Chord or string, it is the same. Chord AM is the diameter of this circle. Because it passes for point O, that is the diameter of the circle. That is the center of this circle. So I will read again what I wrote. Chord AM that I drew is the diameter of the circle because it passes through point O, and point O is the center of the circle. Any chord slash, it is the same, chord or string, it is the same. Any chord or string that passes for the center of the circle is defined as diameter of that circle, and chord AM passes from point O, that is the diameter of this circle. For that reason, chord AM is the diameter of this circle. Again, chord AM passes through point O, that is the center of this circle. For that reason, chord AM is the diameter of this circle. Okay. In the next step, we will connect together points O and M by a straight line. Okay, we connected together points O and M by a straight line. Actually, we have rule number 1 that states a peripheral angle that rests on the diameter of a circle equals to 90 degrees. I will read rule number 1 again. Rule number 1 states that a peripheral angle that rests on the diameter of a circle equals to 90 degrees. I read again. A peripheral angle that rests on the diameter of a circle equals to 90 degrees. I will give you an example in order to clarify rule number 1. Suppose that chord AB or string AB, it is the same, is the diameter of this circle, and we have a peripheral angle that rests on chord AB. Peripheral angle ACB rests on chord AB, and AB is the diameter of this circle. So according to rule number 1, peripheral angle ACB equals to 90 degrees. Okay? Peripheral angle ACB equals to 90 degrees. So I write it down. So peripheral angle ACB rests on chord AB and chord AB is the diameter of the circle so according to rule number 1 it equals to 90 degrees. So I read again what I wrote. Peripheral angle ACB rests on chord AB, and chord AB is the diameter of the circle, so according to rule number 1 it equals to 90 degrees. Okay, so any other angle, any other peripheral angle that rests on the diameter of this circle will be equal to 90 degrees. Okay, so we can implement this rule in our circle. Because you actually have angle ADM that rests on chord AM, and chord AM is the diameter of this circle. Therefore, according to rule number 1, it equals angle peripheral angle ADM equals to 90 degrees. So I write it down. Peripheral angle ADM rests on chord AM that is the diameter of the circle, therefore according to rule number 1, it equals to 90 degrees. So I will read again what I wrote. Peripheral angle ADM, rests on chord AM, that is the diameter of the circle. Chord AM is the diameter of this circle, and peripheral angle ADM rests on chord AM. Therefore, according to rule number 1, it equals to 90 degrees. So it equals to 90 degrees according to rule number 1, because it rests on chord AM, that is the diameter of the circle. So this angle ADM equals to 90 degrees. Okay. In the next step, we will focus on the right triangle ADM. We will define angle AMD as alpha, and angle AMD will be defined as beta. So I will write it down. In the right triangle AMD, angle AMD is defined as alpha, and angle MAD will be, is defined as beta. Okay. So in the right triangle AMD, angle AMD equals to alpha, angle AMD equals to alpha, and angle MAD equals to beta, angle MAD equals to beta, according to our definition. We also know that the sum of the angles in any triangle equals to 180 degrees, and especially it is true for the right triangle AMD. So we can write our first equation that states that the sum of the angles in the right triangle AMD equals to 180 degrees. So alpha plus beta plus 90 degrees equals to 180 degrees. Alpha plus beta plus 90 degrees equals to 180 degrees. It is true for any triangle. The sum of the angles in any triangle equals to 180 degrees, and especially in the right triangle AMD, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus 90 degrees equals to 180 degrees. Alpha plus beta plus 90 degrees is the sum of the angles in the right triangle AMD, and it equals to 180 degrees. Now we will subtract 90 degrees from equation number 1. We will get that alpha plus beta equals to 90 degrees. We subtracted 90 degrees from equation number 1. alpha plus beta plus 90 degrees minus 90 degrees equals to alpha plus beta, and 180 degrees minus 90 degrees equals to 90 degrees. The next step will subtract alpha from equation number 1. So we subtracted alpha from equation number 1. Alpha plus beta minus alpha equals to beta, and 90 degrees minus alpha equals to 90 degrees minus alpha. So we got that beta equals to 90 degrees minus alpha. So equation number 1 states that beta equals to 90 degrees minus alpha. We will connect together points A and B by a straight line. We have rule, I will call it rule number 2. Rule number 2 states that if two peripheral angles rest on the same chord, then they are equal to each other. Or peripheral angles that rests on the same chord are equal to each other. So I read rule number 2 again. Rule number 2 states that peripheral angles that rest on the same chord are equal to each other. I will give you an example in order to clarify rule number 2. Actually, if we have two peripheral angles, angle alpha rests on chord BC, as you can see from the drawing. Angle alpha rests on chord BC, and we have another angle, angle beta, or peripheral angle beta. We have okay, we also have peripheral angle beta that rests on the same chord BC. Okay, again, we have peripheral angle alpha that rests on chord BC, and we also have peripheral angle beta that rests on the same chord BC. So I'll write it down. Peripheral angles alpha and beta rest on the same chord that is to say chord BC. Okay, peripheral angles alpha and beta rest on the same chord BC. Therefore, according to rule number 2, they are equal to each other. That is to say, alpha equals to beta. So I'll read again the things that I wrote. Peripheral angles alpha and beta rest on the same chord BC. Therefore, according to rule number 2, they are equal to each other. That is to say, alpha equals to beta. Therefore, they are equal to each other. That is to say, alpha equals to beta. So, if we have two peripheral angles that rest, or maybe more, yes, that rest on the same chord, or it might be also same arc, okay? I will add here same chord or same arc. So if we have two peripheral angles that rest on the same chord or same arc, then they are equal to each other. In this example, we have two peripheral angles alpha and beta that rest on the same chord BC, therefore they are according to rule number 2, they are equal to each other. That is to say, alpha equals to beta. And again, you can implement rule number 2 in our circle. Because we have peripheral angle AMD that equals to alpha, peripheral angle AMD equals to alpha, and it rests on chord AD. Okay, peripheral angle AMD that equals to alpha rests on chord AD, and peripheral angle ABD also rests on the same chord AB. Therefore, according to rule number 2, they are equal to each other. That is to say, peripheral angle ABD equals to alpha. So I will read again what I wrote. Peripheral angle AMD that equals to alpha rests on chord AD. Peripheral angle AMD that equals to alpha rests on chord AD. And peripheral angle ABD also rests on the same chord AD. Peripheral angle ABD, again, peripheral angle ABD also rests on the same chord AD. Okay? Therefore, according to rule number 2, they are equal to each other. That is to say, angle ABD equals to alpha. Okay, angle ABD equals to alpha. Okay, because angle ABD rests on the same chord as angle alpha. Therefore, according to rule number 2, they are equal to each other. That is to say, angle ABD also equals to alpha. So, I write here that angle ABD equals to alpha. Angle ABD equals to alpha because both angle ABD and angle alpha rest on the same chord AD, so according to rule number 2 they are equal to each other. So if this angle is alpha, so this angle will be also alpha. So angle ABD equals to alpha. Okay? So in the next step we will define angle BAC as x. Okay? Angle BAC will be defined as angle x so I write it down. Angle ABC will be defined as x, so maybe before that I will define the vertex of this right angle L. Okay, the vertex of the right angle is defined as L, and in the right triangle ABL angle BAL is defined as x. Okay, in the right triangle ABL, angle BAL equals to x. Again, in the right triangle ABL, angle BAL, this angle is defined as x. As I already told you, the sum of the angles in any triangle equals to 180 degrees, and especially it is true in the right triangle ABL. The sum of its angles equals to 180 degrees. So actually alpha plus x plus 90 degrees equals to 180 degrees. So we will create our second equation that states that the sum of the angles in the right triangle ABL equals to 180 degrees. That is to say alpha plus x plus 90 degrees equals to 180 degrees. The sum of the angles in the right triangle ABL equals to 180 degrees, or alpha plus x plus 90 degrees equals to 180 degrees. That is the sum of the angles in the right triangle ABL. Now we subtract 90 degrees from equation number 2. So we subtracted 90 degrees from question number 2. Alpha plus x plus 90 degrees minus 90 degrees equals to alpha plus 6, and 180 degrees minus 90 degrees equals to 90 degrees. Here we will subtract alpha from the second equation. So we subtracted alpha from this equation. Alpha plus 6 minus alpha equals to x, and 90 degrees minus alpha equals to 90 degrees minus alpha. This is our second equation, but from this first equation we know that from the first equation we know that beta also equals to 90 degrees minus alpha. So I write it down. So from the first equation we know that beta also equals to 90 degrees minus alpha. Now we will integrate equation number 1 and 2 in order to find out the value of x. So our second equation states that x equals to 90 degrees minus alpha. So I copied our second equation here, x equals to 90 degrees minus alpha, x equals to 90 degrees minus alpha. But from the first equation we know that 90 degrees minus alpha equals to beta. From the first equation we know that 90 degrees minus alpha equals to beta. So I will add this equality to this equation. Okay, we know from the second equation that x equals to 90 degrees minus alpha. I copied the second equation here, x equals to 90 degrees minus alpha, and from the first equation we know that 90 degrees minus alpha equals to beta. So I add here that 90 degrees minus alpha equals to beta, because this is exactly equation number 1. 90 degrees minus alpha equals to beta. Okay, so from this equality we can deduce that x equals to beta. Okay, x equals to beta. So we know that x equals to beta. So instead of x we can substitute it by beta, because x equals to beta. We know that x equals to beta, so we can substitute x by beta. Okay, instead of x, I will write here beta. So angle angle BAL equals to beta. Okay. We have rule number 3. Rule number 3 states that equal peripheral angles rest on equal chords. Okay, equal peripheral angles rest on equal chords or equal arcs. So I will read again rule number 3. Actually, rule number 3 states that equal peripheral angles rest on equal chords or equal arcs. In order to clarify rule number 1, I will give you an example that explains the rule. If we have two peripheral angles that are equal to each other, for example, we have peripheral angle alpha in the black color, okay, we have here peripheral angle alpha in the black color and peripheral angle alpha in the black color rests on chord BC. Okay, and we have another peripheral angle alpha in the red color Okay, we have another peripheral angle alpha in the red color and peripheral angle alpha in the red color rests on chord EF. Okay, so those two peripheral angles are equal to each other, both of them equal to alpha. Okay, so according to rule number 3, they rest on equal chords. That is to say, BC equals to EF. Okay, so I'll write it down. Because of the fact that those peripheral angles are equal to each other, therefore according to rule number 3, they rest on equal chords that is to say, BC equals to EF. So I read again what I wrote. Because of the fact that those peripheral angles are equal to each other, both those peripheral angles equal to alpha, so they are equal to each other. Therefore, according to rule number 1, to rule number 3, therefore, according to rule number 3, they rest on equal chords. The red angle alpha rests on EF, and the black angle alpha rests on chord BC. And according to rule number 3, because of the fact that they are equal to each other, they also rest on equal chords. That is to say, BC equals to EF. Okay? So we can implement rule number 3 in our circle. Angle CAB equals to beta, and it rests on chord BC. Angle ACB that equals to beta rests on chord BC. While angle MAD that also equals to beta rests on chord MD. So therefore, because of the fact that those two angles are equal to each other, both of them equal to beta, so according to rule number 3, they rest on equal chords. That is to say, BC equals to MD. Therefore, according to rule number 3, they rest on equal chords. That is to say, chord BC equals to chord AM. Chord BC equals to chord MD. Again, angle BAC that equals to beta rests on chord BC, and peripheral angle MAD that also equals to beta rests on chord MD. And according to rule number 3, they rest on equal chords. So BC equals to MD. So I'll read again what I wrote. Angle CAB that equals to beta rests on chord BC. Angle CAB that equals to beta rests on chord CB or BC. BC doesn't matter. While angle MAB rests on chord MD, while peripheral angle MAD rests, that also equals to beta, rests on chord MD. Okay, therefore, so both of those two angles equal to beta. Therefore, okay, so I'll add here. Okay, so both those two angles equal to beta. Therefore, according to rule number 3, they rest on equal chords. That is to say, BC equals to MD. So because of the fact that those two angles are equal to each other, therefore, according to rule number 3, they rest on equal chords. That is to say, BC equals to MD. Okay? Because of the fact that those two angles are equal to each other, they also rest on equal chords. That is to say, BC equals to MD. Okay? So we arrive to the conclusion that BC equals to MD. Okay, according to rule number 3, BC equals to MD. But we know from it is given us in the question that BC equals to 5 units. Okay, so I can add here that BC equals to 5 units. Okay, according to what is given us in the question, BC equals to 5 units. So from this equality we can deduce that MD also equals to 5 units. Okay, MD equals to 5 units. Okay? So the conclusion from this equality is that MD also equals to 5 units. So we can write here that MD equals to 5 units, okay? So in the next step I will draw again the right triangle AMD. So I draw again the right triangle AMD. Side AD equals to 10 units, side MD of the right triangle equals to 5 units. And actually note that AM is the diameter of this circle. So I will mark AM as D, that is the abbreviation for diameter. Okay? AM will be defined as D, that is the diameter of the circle, and you can use the Pythagorean theorem in order to find out the value of D, that is AM, or in order to find out the value of the hypotenuse in this right triangle. So actually the Pythagorean theorem states that in a right triangle, the Pythagorean theorem applies only on right triangles. So in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So I will read again the Pythagorean theorem. The Pythagorean theorem states that in a right triangle, as I already told you, it applies only right triangles. It is not correct. The theorem is not correct if it is not right triangle. So in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So we can implement this theorem in our right triangle. The square of the hypotenuse is AM square equals to the sum of the square of the perpendiculars. That is to say, equals to AD square plus MD square. This will be our third equation. So our third equation states that AM squared, that is the square of the hypotenuse, equals to the sum of the square of the perpendiculars, equals to AD square plus MD square. But we know that AM equals to D, AD equals to 10 units, and MD equals to 5 units. Okay. So we can substitute AM by D, AD by 10, and MD by 5. Okay. Okay, here we substituted AM by D, AD by 10, and MD by 5. Ten square is 100 and 5 square is 25, so 100 plus 25 equals to 125, so I write it down. So in the next step we'll take a root out of equation number 3. So we got that D equals to root of 125. 125 equals to 25 times 5, so I write it down. Okay. D equals to 25 times 5 because 125 equals to 25 times 5. Now we can split the root to 2 roots according to the rule that the root of AB equals to root A times root B. So we can write that E equals to root 25 times root 5. So according to the rule that the root of AB equals to root A times root B, we can write that the root of 25 times 5 equals to the root of 25 times root 5. The root of 25 is 5, so I write it down. So here the root of 25 is 5. So we got that d equals to 5 times root 5 because it is 5 times root 5. We know that the diameter of any circle equals to 2 times the radius. So I'll create the fourth equation that states that the diameter of any circle equals to 2 times the radius. D is actually the diameter of the circle because D equals to AM, and AM is the diameter of the circle. So D that equals to AM is also the diameter of the circle, and the diameter of any circle equals to 2 times the radius. So this is our fourth equation. But we know that the value of d is 5 times root 5, so we can substitute d in the fourth equation by 5 times root 5. So we'll do it now. So we substituted d by 5 times root 5 because d equals to 5 times root 5. We got that 5 times root 5 equals to 2 times the radius. We'll divide equation number 4 by 2 and we'll get the radius of the circle. So we divided equation number 4 by 2 and we got that the radius of the circle equals to 5 times root 5 over 2 units. Or we can also write that the radius of this circle equals either 5 times root 5 over 2 units, so we can write it in the terms of numbers. So we also can write that the radius of the circle equals to 5.59 units. Okay, so the answer to the question is that the radius of the circle is either 5 times root 5 over 2 units, so it is also can be written as 5.59 units, okay? So now I will summarize the lecture. So we actually wanted to find out the radius of this circle, and we know that chord AD in the circle equals to 10 units, chord BC in the circle equals to 5 units, and the center of the circle is at point O, and this angle is 90 degrees, and we want to find out the radius of this circle. Okay. First of all, we define the term of a peripheral angle. A peripheral angle is an angle inside the circle. Its vertex is on the circle and its curves are curves in the circle. Okay, uh, I showed you an example of a peripheral angle in order to clarify the theorem as much as possible. So this is peripheral angle alpha, or alpha is a peripheral angle because of the fact that peripheral angle alpha is inside this circle, and point O is the vertex of angle alpha, and point also is on this circle, and curve AB of angle alpha is chord in this circle, and also curve AC of angle alpha is chord in this circle, and angle alpha is rests on chord BC in the circle. So this is the definition of a peripheral angle, and actually the next step, we draw a chord for points A and O, and we defined the touching point between the circle and the chord as point M. So actually chord AM is the diameter of the circle because it passes through point O, and point O is the center of this circle. Therefore, chord AM is the diameter of the circle because any chord, any string is the same. Any chord that passes through the center of the circle is defined as the diameter of the circle. Okay, for that reason, AM, chord AM that passes through the center of the circle is defined as the diameter of this circle. And actually we have rule number 1 that states that a peripheral angle that rests on the diameter of a circle equals to 90 degrees. So actually I gave you an example of a peripheral angle that rests on the diameter of a circle. Suppose that AB is the diameter of this circle, and actually peripheral angle BCA rests on chord AB that is the diameter of the circle. For that reason, and for peripheral angle BCA equals to 90 degrees according to rule number 1. Okay, so we actually implemented this rule in our circle because we have peripheral angle ADM that rests on AM, and AM is the diameter of this circle. Therefore, according to rule number 1, it equals to 90 degrees. Okay? Then we focus on the right triangle AMD. In this right triangle, we define the angle AMD as alpha and angle MAD as beta. We know that the sum of the angles in the right triangle AMD equals to 180 degrees. So we created equation number 1 that states that alpha plus beta plus 90 degrees equals to 180 degrees. Alpha plus beta plus 90 degrees, it is the sum of the angles in the right triangle AMD, and it equals to 180 degrees. Okay, so we got that beta equals to 90 degrees minus alpha. Okay, but we got that beta equals to 90 degrees minus alpha, and we actually have rule number 2 that states that peripheral angles that rest on the same chord or same arc are equal to each other. So I gave you an example of rule number 2. we have two peripheral angles, alpha and beta, that both of them rest on the same chord BC, therefore they are equal to each other according to rule number 2, therefore alpha equals to beta. We implemented this rule in our circle because we have peripheral angle AMD that equals to alpha, and we have peripheral angle ABD that rests on the same chord AD. Peripheral angle AMD that equals to alpha rests on chord AD, and peripheral angle ABD also rests on the same chord AD. So according to rule number 2, they are equal to each other. That is to say, if this angle is alpha, this angle is also alpha. Okay? Because peripheral angles that rest on the same chord AD are equal to each other. This angle equals to alpha and it rests on chord AD, and this angle also rests on chord AD. So according to rule number 2, they are equal to each other. That is to say, angle ABD also equals to this angle alpha that rests on the same chord AD. So this angle ABD also equals to alpha. Okay? And actually, in the right triangle ABL, we know that this angle is alpha. We define the angle BAL as x, and we know that the sum of the angles in any triangle, and especially in the right triangle ABL, equals to 180 degrees. So we can write that x plus alpha plus 90 degrees equals to 180 degrees. Okay, in the second equation states that the sum of the angles in the right triangle ABL equals to 180 degrees. Okay, we got actually from the second equation that x equals to 90 degrees minus alpha. But we know from equation number 1 that beta also equals to 90 degrees minus alpha. So from equation number 2, we know that x equals to 90 degrees minus alpha. And from equation number 1, we know that 90 degrees minus alpha equals to beta. 90 degrees minus alpha equals to beta. So we integrated these two equations, and we got, so from the first equation we know that beta equals to 90 degrees minus alpha, and from the second equation we know that x equals to 90 degrees minus alpha. So by the integration of those two equations we conclude that x equals to beta. Okay? So actually we substitute angle x by beta, and we also have rule number 3 that states that equal peripheral angles rest on equal chords or equal arcs. An example of this rule is here. We have two peripheral angles that both of them equals to alpha. The black alpha rests on chord VC and the red alpha rests on chord EF. So because of the fact that both angles are equal to each other, both of them equal to alpha, according to rule number 3, they rest on equal chords. That is to say, BC equals to EF. Okay, so we implemented this rule in our circle because we have angle CAB that equals to alpha and it rests on chord BC. And we have also angle MAD that also equals to beta and it rests on chord MD. Again, angle CAB equals to beta and it rests on chord BC, while angle MAD that also equals to beta rests on chord MD. Okay, so according to rule number 3, because of the fact that those two angles are equal to each other, both of them equal to alpha, they also rest on the same, on equal chords. Because of the fact that those two peripheral angles are equal to each other, they also rest on equal chords. That is to say, BC equals to MD. Okay? But we know that BC equals to 5 units. It is given us in the question. From rule number 3, we know that BC equals to MD, but we know from the question itself that BC also equals to 5 units. So from this equality we can deduce that MD equals to 5 units. Okay? So we can write here that MD equals, we wrote here that MD equals to 5 units. And I draw the right triangle AMD again, and chord AM is the diameter of this circle, so we call it D, abbreviation for diameter. Side AD equals to 10 units, side MD equals to 5 units, and we can use the Pythagorean theorem in order to find out the value of D. Okay, the Pythagorean theorem states that in a right triangle the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so we can implement this rule in our right triangle. According to the Pythagorean theorem, AM square equals to AD square plus MD square. Okay? So this actually, this is our further question that states that AM square equals to MD square plus MD square, but we know that AM equals to D, that is the diameter of the circle, AD equals to 10 units, and MD equals to 5 units. So we can put the data in equation number 3 in order to find out the value of AM. We put the data, we got that D square equals to 10 square plus 5 square, and at the end we found out that D equals to 5 times root 5. Okay, but we know in general that the diameter of any circle equals to 2 times the radius, and D is the diameter because it equals to AM, and AM is the diameter of the circle. Okay, so from one side D equals to 2 times the radius, but we know that D also equals to 5 times root 5, so we can substitute the D in the fourth equation by 5 times root 5. So we substituted D by 5 times root 5, and we got that 5 times root 5 equals to 2 times the radius. We divided the equation by 2, and we got that the radius of the circle equals to 5 times root 5 over 2 units, so we can also write it in the terms of numbers that the radius of the circle equals to 5.59 units. Okay, so the radius of this circle equals either to 5 times 59 units, or we can also say that the radius of the circle equals to 5 times root 5 over 2 units. Okay, thank you very much.